Okay, we'll consider the statement, you will work hard and pass the test, or you will not get an ice cream cone. Now, the way this is read depends on who's talking to you. If it's your mama talking to you, it means one thing. If it's logic, it might mean something just a little bit different. Okay, if it's strict logic, which is what we're talking about here. This is not an exclusive or, just plain old or. If your mama's saying it to you, it probably means if this happens, this won't, or this will, and if this doesn't happen, this won't, and this won't happen if this doesn't happen. It's not quite what the or means in logic. Notice we have, let's see, work hard, we'll call that P. Pass the test, we'll call that Q. And get an ice cream cone, we're going to call R. So our three conditions here are P, Q, and R. The three things that can happen. Symbolic representation of that is you work hard and pass the test, that's P and Q. Comma, or, so we group the P and Q, that's all part of this phrase before the comma, so we group it, and we represent the or as the or symbol. You will not get an ice cream cone, not R. We want to evaluate the truth of this statement. We're going to need columns for P and Q and R, and then we're going to need a column for P and Q, and we're going to need a column for not R so that we can evaluate the or. The or is an or between P and Q and not R. So finally we can evaluate P and Q or not R in this column here. I've written that up a little higher just so we aren't squeezed by the margins in the column. How are we going to list values for P, Q, and R? We have three propositions, or three conditions now, P, Q, and R. Well, we start the way we always do. We take the last one and we'll call it either true or false. And then in front of that we'll put trues. And then we'll call it either true or false, and in front of that we'll put falses. Now we've listed all four possible truth values for Q and R. Let's put true in front of all those. So now we have every possible combination of truth values for which P is true. Now if we take the four truth values for Q and R and repeat them again, true, 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 false, false, true, false, false, and then put false in front of each one, we'll have all possible truth values for P, Q, and R. If we want to do P and Q, what do we do? Now the and is called a conjunction, so we look at the conjunction between P and Q. Conjunction means they both have to be true in order for the statement to be true. So P and Q, if P and Q are both true, of course, that makes it true. Here again, P and Q are both true, so this statement will be true. But in each remaining case, in each remaining line, one or the other statement, or both, happens to be false, so the and will certainly not be true and will have false in each of the remaining cases, on each of the remaining lines. Okay, not R. To evaluate not R, we look back at the R line and we simply make the truth value the opposite. So if R is true, we're going to get false. If R is false, we're going to get true. So we got a true, so a false, and a false becomes true, and we keep doing that. Whoops. Clerical error there. That's a false, this is a true. So now to evaluate the total statement, we want to evaluate P and Q or not R. That means we're evaluating the truth of this column, the truth of this column with an or. The or will be false only when both this column and this column are false. Now where does that happen? Let's just scan down the column. We see that there's a case here. And we see that there's a case here where they're both false. And we see that there's another case here where they're both false. Now, in the other cases, let's see, we have a true and a false, which makes it true, true and a true, which makes it true, false and a true makes it true, false and a true makes it true, and a false and a true again makes it true. So now we've evaluated the truth values for the statement. And we see that the statement is false when, let's see, P and Q are both true and Q is false. Now we're saying P and Q, so if Q is false, that makes the P and Q false. And if the R is false, that makes this false, so we get a false. You can interpret every line in terms of whether P and Q, whether P, Q, and R are each true or false. In any case, this is a demonstration of how we evaluate this compound statement using a truth table.